So area and circumference of a circle. You guys remember what the formula is for the area of a circle without looking. Area is pi r squared. Okay. And the circumference of a circle? 2 pi r. Or you may say pi times your diameter. Okay. Because 2 times your radius is the length of the diameter. So I'm not going to spend too much time on this because I know you guys have a lot of background on it, but I'm just going to go over a couple problems involving this. So for this first circle in number 1, we have a radius of 12 meters, and we're asked to find the area. And so the area is going to be pi r squared, so pi times 12 squared, which is 144 pi. And then for your final answer, just bring the units back in. So we're looking at meters, but it's area, so it's going to be meters squared. Whenever we're working with area, you're going to have units squared. When you're working with volume, you're going to have units cubed. And then length would just be that unit. Lena, question? I'm okay with either. If you have an integer in front of pi, leave it like that. But if you get this crazy decimal, then just multiply it with pi and get a decimal. And you'll start to see the instructions change when we get to those. They'll say round your answer to the nearest 100th. If you're seeing that, then just throw everything in and just don't leave it in terms of pi, just get the decimal. Okay, you'll see those come up. So number 3, it says to find the radius of a circle with a circumference of 35 pi yards. Go ahead and solve number 3. Atticus, did you get number 3? How'd you do it? How'd you start? So we know the circumference is 2 times pi times r, right? Were you thinking area? Okay. So the circumference is 2 times pi times r. So if I put 35 pi in place of the circumference, I get 2 pi times r. And then that can help us find the radius. We want to end up, well, that's actually what we want to find, the radius, right? And so what would you do to solve for that radius? Divide out pi. So if you divide both sides by pi, you get 35 is 2 times the radius. So the radius is 17.5 by dividing. And we're looking at yards, so bring that back in. 17.5 yards. So sometimes you start with, you got to work backwards, right? They give you the circumference, you got to find the radius. Next one I want you to try is 15. Find the area of a circle that has a circumference of 26 pi feet. Jonah, what do you do in 15? So how'd you get it? Okay, so 26 pi is our circumference, and that's equal to 2 pi r. Divide that with the pi, so you get 26 equals 2r. We get 13 for our radius, and then you squared it. Sorry, pause this here. So what's the formula for area? Pi r squared, right? Did you have the pi? Oh, okay, good. So pi times 13 squared, which is 169 pi. And then what are the units? Feet squared. Good. Perfect. Okay. So those are the kinds of questions you'll see regarding area and circumference. So arc length is a portion of the circumference. So if you know the whole circumference, you're going to find maybe a fraction of it. And so let me give you an example. So say I have a circle here, and I tell you that the circumference is 100 centimeters or some length there, right? That's our circumference. And I want, so I pick a couple points on the circle. So here's point A, here's point B. And I'd like to know the distance, the shorter distance from point A to point B, going along the circle. If I tell you that the angle, the central angle here, is, say, 120 degrees, what would that distance from A to B equal? How could we figure that? If the distance all the way around that circle is 100, and I just want the distance from A to B, which is a part of that distance, you give it as a fraction. What would the fraction be? Yeah, 100 over 3. How'd you do that? Yeah, this is 120 is a third of 360. Or another way to look at it, if you have 120 out of 360, that reduces to 1 over 3. And so we're talking about a third of this circle. And so if the full thing is 100, we're going to take a third of 100, and that's 100 over 3. Okay, so that's exactly what we're doing for the arc length formula. So if we have a circle that has a central angle x degrees, and we want to find the arc length from this point A to point B here, we're going to find out, well, what fraction of the circle are we working with? So we're going to take that x and divide it by 360. That's the fraction. And then we're going to multiply that by the circumference. So that times the circumference. And that's how you find the arc length. So try that with number 7. April, can you share what you tried on number 7? Okay, so found the circumference of the circle, and so 2 times pi times r. What's r in this case? 15. That says EB is 15, so that's this length here. And so you get 30 pi for the circumference, okay? $68 over 360. And you multiply that by 30 pi. So you're finding the distance from where to where? So if I did this, okay, what did you find the distance from? Where to where? Good. So that would find the distance from B to C. We want C to D, so we're going to have to adjust it a little bit. And I know you just caught that mistake. You see how we can adjust it a little bit? Find that angle there, good. And do you see a way to find that angle? Good. Anybody do that already, guys? What do we get? 180 minus 68? 112? Okay. So instead of 68 at that numerator, we're going to put 112 there. Okay. And so this should give us the arc length of CD. And so if we type all that into our calculator, what are we coming up with? Anybody? 29.31 or 32? And what units should we use here? Centimeters or centimeters squared? Just centimeters because it's just a length. Okay. Use squared centimeters for area. Okay, now let's skip to number 10. On the next page, try this problem out. Okay. Kateri, can you share what you did on number 10? Okay, so Kate, so you found that this is 26? How did you find that 26? Blaine, it's a great thing. Yes, but how do you know? Why did you do 85 minus 69? For us that don't see why. I want her to explain. What's that? Okay, so we have vertical angles here. This 85 is vertical with this full angle here. And so that whole thing's 85. So the small angle, the KLG, is going to be, so the measure of angle KLG will be 85 minus 59. Did you want to say something? Well, what did you get? What's 85 minus 59? 26. Okay, so we got 26 degrees there. And then what'd you do? So now you're looking for the measure of the bigger one, right? So the complement of that, or sorry, not the complement, but the rest of that. So 360 minus 26 gave you 334, and that's I'll use a highlighter here. That's all this angle here minus that 26. So great. Now what? Good. So you notice that they gave us the diameter, so we just need to do pi times 21 or 21 pi, and then keep going. And what'd you get? 61 point. Now give me 2 decimals. You have a 2-1. And anybody else get that? Okay. And then what's our units? Good. Perfect. Thank you. All right. So that's arc length. Arc length is a fraction of the circumference. Okay, and those are kinds of problems that you would do to find arc length. Now, just like an arc length is a fraction of a circumference, a sector is a fraction of the area of the circle. It's a piece of the pie. Okay. So a sector is a central angle of a circle bounded by the circumference. And its intercepted arc. Actually, let's rephrase this. I know. I probably put the words in the wrong place. Let's try this. A sector is a part of a circle bounded by a central angle and its intercepted arc. That works better, huh? And think of a sector like a slice of pie. Not PI, but PIE, okay? So in the same way, a sector is a fraction, so we're going to have that x over 360, but this time we're going to multiply it by the area of the full circle. So times the area of the circle. So you're finding a fraction of that full area. So in number 11, if I want to find that area here, I'm going to say, well, okay, I want the area of the shaded region. The central angle is 120 degrees out of 360 times the area of the circle. The area of the circle is pi times the radius squared, so pi times 22 squared. And then I multiply all that together and round to the nearest hundredths. Type that into my calculator. So I'm gonna type in 22 squared first times pi times 120. We could reduce that fraction first, but since we're using a calculator, we don't need to. And then I'm going to divide all of that by 360. And I get 506.84. What are my units? Centimeters squared, because now we're looking at area, okay? So I want you to try the same thing on number 16. Madison, what'd you do? Share with us what you did on 16. Okay, so how do you know that all those are 60? Or was that something you were assuming? You're assuming it? And maybe that's a safe assumption. Maybe it's not. Any comments on that? We'll come back to, yeah, what do you think? Okay, for the non-shaded regions, the arcs are congruent. So we could say that this is 60 and this is 60 for sure. Okay. It looks crooked to me. Doesn't look like a diameter to me. It's like kind of bent, you know? If you go from E to P, it kind of bends a little bit there. I don't know. It doesn't look straight to me. Okay. So if you restructured this and put if you put all the shaded regions together and put the non-shaded regions together, so the non-shaded regions we know those, right? And that adds up to 180. And so we don't know what the shaded regions are. This may be 59, this may be 61. So, but we do know they have to add up to 180. So our shaded region ends up being half of a circle. Okay, now keep going. You mean the area of the circle? Area of the circle is pi r squared. So pi times 12 squared. So that's 1/2 times 144 pi, or 72 pi. And what is it? Did you get a decimal value for that? What'd you get? And what are the units? Okay? Good job, Madison.